Okay, I'm back, and in the previous segment we were talking about eclipses of the sun and eclipses of the moon, and now we want to talk about in this segment about what is it that causes the seasons. But before that, I need for you to do a little experiment for me. So I need for you to get out a flashlight and a piece of paper, and then put the piece of paper on a table in front of you, and then take your flashlight and shine it straight down onto the piece of paper and see what it looks like. Okay, you should notice that it makes a bright circle. Now I want you to take the flashlight and I want you to shine it at an angle and try to make it so that the distance from the end of the flashlight is the same distance to the tabletop as it was this way. And then what do you notice? You should notice two things. You should notice that the circle has turned into a ellipse, and you should also notice it got a little bit dimmer when you did that. So it's the same amount of energy coming out of the flashlight, whether you do it this way or this way, but because that energy is spread out over a larger area, therefore the intensity has decreased. So now we're going to use that concept to explain the seasons. Okay, but before we do that, let's do another thought experiment, or you can do this one at home with a piece of paper. But imagine that the earth was flat. Okay, and so if you were to take your piece of paper now and hold it so that the paper is going up and down, and now take your flashlight, shine it at the bottom of the piece of paper, so we'll call that the equator, and then shine it at the top of the piece of paper, we'll call that the North Pole. What do you notice happens? Well, it's not very exciting. So did you notice that it was the same brightness at the equator as it was up at the North Pole? So that if the earth was flat, there was no curvature to the earth, then that would mean that it would be the same temperature everywhere on the earth. So that at the equator it'd be a certain temperature, but it would be the same temperature up at the North Pole. Now what I want you to do is, you might need some help with this, if you take your piece of paper and curve it like this, and then take your flashlight and shine it down at the bottom of the paper, which represented the equator, okay, and then shine it at the top of the piece of paper, which represented the North Pole, you should notice something, that the brightness of the flashlight was more intense where? At the equator. So that means, what about the temperature? So the temperature would be hotter at the equator than it would be at the North Pole. So if the earth was like this, okay, so if it spun so that the spin axis was straight up and down, then it would be hot at the equator and it would be cold at the North Pole due to just the amount of sunlight that it gets and the angle that the light is coming in at. And then in between, like here in Missouri, it's going to be in between being too hot and too cold, so it'd be just right here. Now in our next segment, we're going to talk about what happens when the earth is tilted. So I'll see you then.